Yeah. So I really enjoyed all the talks, but I have a question for Elise. For a project like the Houghton Mars project, where we've been at it for a quarter century, would there be resources if we were to undertake archiving? I mean, first of all, our stuff is archived in different ways already, but if we were to sort of put it into this integrated program that you are proposing, would there be resources to support that magnitude of effort?
All right, yeah, something that large. So yeah, something that large might need some extra resources. Yeah, things that are on, a smaller basis. So yeah, I don't know how to explain the scale of things, but yeah, we're a small team, so we don't have a ton of time to dedicate to really large projects like that. But that's something, if you wanted to work together, we could think about writing a PDART or something like that to try to get funding for a project to that scale.
Okay, great. Yep. So I'll be in touch. Thank you.
Yeah, thank you.
Excellent. Thank you, everybody. Let's open it up now for questions for all of our speakers from the last few hours. We can have our discussion session. So if you have a question, please feel free to come up to the mic here in the room, or if you're online, raise your hand or make yourself known to Oz. In the room, yes.
Hi there, Jack Hostrasser, University of Western Ontario. I have a slope question.
Shoot.
You talked about, I think, if I heard it correctly, that your astronauts felt empowered to go a little further onto steeper terrain when given that slope data. Can you comment on what the terrain was like underfoot? And like was it loose and friable? Was it like pebbles on rock?
Yeah, sure. So it was it's a Mar crater with beautiful surge beds exposed in cliffs that shed little pebbles, sometimes cobbles into the scree slope. And so where people were walking typically was a kind of slope dip area of the surge beds that was a little bit indurated, and then there were kind of pebbles and ash and gravel kind of superposed on top of that surface. And so I would say it's in some places it was more solid and in easy footing, and so other places it was kind of that gravelly, difficult marbly terrain.
Okay, so it sort of varied even though the slope might have been consistent.
Yeah.
Okay. Cool.
Yeah, thanks. But it's a good consideration. There's more to traversability than just a simple slope measurement, for sure.
Yeah. Thanks.
In the room, yes.
Hey, Zach Morris, Howard University, NASA Goddard. This is another question for you, Patrick, about your slope. Simple one. You had a picture of a really neat device that was a level with 2 feet on it. Is that something that's available for folks to purchase and then incorporate into future field operations?
Yeah, it's a commercially available device. It's even there's even a company. The company that makes those devices actually will come out and survey your job site or trail system or whatever for you, and they'll use that device as they also have a little push cart with a slightly different device on it. It's a little quicker to use, I think, but yeah, we could at minimum get one and use it ourselves.
Thank you.
Brian Day, NASA Survey, and Patrick, to you again. So one of the things the Apollo astronauts encountered was especially problems with navigation, with lighting, and the actual phase angle. And so have you considered looking at what you would consider to be a comfortable slope, but under different phase angle lighting effects?
Yeah, that's a good question. I haven't done that, but I believe the jet test group would be the ones that I would think of have the best kind of angle on that, because they're using the harsh lighting conditions, or they're simulating the harsh lighting conditions that we expect in the South Pole. And I wonder how you could tell what the perception of that slope would be. But that's a really good question. I wonder if that's something we could quantify. Also, potentially, Aardvark could comment on that. The P-star. Yeah. Go ahead, Alex.
Hi, Alexandra Mathieu-Novak from the Applied Physics Lab. This question is for Oz. You had mentioned that out in the field, it was difficult to differentiate between volcanic and impact melt rocks. And I was wondering if it would help, if that's a situation where it would help to have some kind of handheld field spectrometer out there with you, if that would be a way to help differentiate.
Yeah, that's a great question. Thank you. I don't know, thinking off the top of my head, if any kind of suitable spectrometer would exist. Chemistry could be the same for volcanic or impact generated melts. I don't know if Clive Neal is in the room. I saw him earlier in a different session. One of the only ways they've been able to do it with Apollo samples so far is to use crystal size distribution in a lab with thin sections. And so, yeah, I don't know if we have the technology right now, but it's something interesting to think about. And it sure would be nice to be able to, have some kind of field tool to be able to differentiate things in real time.
Hello, my name is Ruth Nichols. I'm a student at Florida Tech. I have a question for Zach. So how did you select the astronauts for your studies? Were there any strict selection criteria?
Yeah, thank you. So in this case, we were looking at going to the Kilburn Hole analog site, and we essentially needed 8 volunteers who were familiar with geology, but not super familiar with that field site, because we wanted their first impression of the area to be part of the test. So it was folks who were related, either co-Is on the RISE 2 proposal or sort of students of them that we pulled in, and some of the GEOS collaborators as well to participate for that one. So in the past, we'd actually had less stringent contingency or restrictions on who could be an astronaut. And there was a great presentation in an earlier session today from Zach Dowdy at Stony Brook University, where they part of the RISE 2 program was getting journalism students involved. And so in the past, we actually did have some of those students who had no experience in geology sort of give their impressions on just simple traverses or simple observations. But this year it was a little more technical. So it was, yeah, some folks with geology experience.
Okay, thank you.
Thanks.
Any questions online, Oz?
None so far, Patrick.
Any more in the room here? Okay, well, I think we'll close. Thank you very much, everybody. Thank you very much to all of the speakers. Thank you, everybody online, and thank you for being here in the room. I hope you had a good session and have a nice rest of your day.